Welcome to Math Local. Now we'll discuss circles lesson, theorem number 10.1. The theorem is the tangent at any point of a circle is perpendicular to the radius through the point of contact. That means the tangent at any point of a circle. So this is a figure. This is a tangent. This is a circle. The tangent is touching at the point P. At this point, the radius and this tangents both are perpendicular. We need to prove both are perpendicular. Just write the given information. Given a circle with center O, xy is the tangent through the point of contact P, through the point of contact P, and required to prove RTP, required to prove. So what do we need to prove? Radius is perpendicular to tangent and radius is OP is perpendicular to tangent XY. We need to prove this one. OP is perpendicular to XY. And we need a small construction to prove OB is perpendicular to XY. Actually the proof is very simple. This is a very simple proof and a very simple process also. When we need to prove OP is perpendicular to XY, then we need to prove that OP is nothing but a radius. This radius is the shortest distance from center to the point on the tangent. That means if you take a different points on the tangent, I'll just take here one point Q, here another point S. I'll join OQ and OS. If you observe, S, P and Q are the different points on the tangent. The distance OQ and the distance OS and the distance OP, among these three distances we need to prove OP distance is the shortest distance than OQ and OS. If you are able to prove OP distance is shortest distance, OQ distance is greater than OP, or OS distance is greater than OP, that means OP only if distance is shorter than the remaining two distances from the center at any point on the tangent, then it is proved that the shortest distance only the radius, and that should be the perpendicular to the tangent. But to prove, we no need to take a different points, so we can take one point on the tangent, which is enough. So I will not take 2 points and 3 points on the tangent. I will just take only 1 point on the tangent, and I will just prove OP is the shortest distance. So I will just take some other point on tangent Q. So I will just take another point on XY. So another point Q on XY, which and I will join OQ, which touches the circle at R point. So I'll just take this point is what point? R point I will take. Now I'll just go for the proof. It is very simple, very few steps only we have here. Then I'll just see here this figure. OP is the radius and OR is also a radius, and we know that radii of a same circle are equal. I'll just start with OP is equal to OR. I'll just write this is radii of a circle. And if you observe, we have a OQ line segment is there. On that OQ middle we have R point also is there. That means OQ is the total distance and OR is the in that sum part. So as per Angsen, we have Angsen, whole is always greater than the part. Then here OQ is a total part. OQ is a total part. This is always greater than the in that sum part of distance OR. OQ is greater than OR. Now I'll just write OQ is greater than OR is equal to OP. Instead of OR, I will just write OP. Then I got here OQ is greater than OP. That means OQ distance is longer than OP. In another way, we can say OP distance is the shortest distance than OQ. So it is proved that OP distance is the shortest distance than any other distance from the center to the points of the tangent. It is proved that. So we can say OP is perpendicular to XY. So let's write OP is the shortest distance to the tangent from its center O. So therefore I can write OP is perpendicular to XY, the shortest distance only the perpendicular to the tangent. So we can write OP is perpendicular to XY tangent. Hi, welcome to Math Loka. Today we will discuss the theorem in circle. The theorem 10.2. The lengths of tangents drawn from an external point to a circle are equal. That means the lengths of tangents drawn from an external point. So if you consider this is a circle, P is an external point. P onwards we can draw two tangents. One tangent name is AP, another tangent name is PB. So we have to prove in this theorem, these two tangents are equal. That means AP is equal to BP. We have to prove AP is equal to BP. So for that I'll just start with the given information. I'll just write. So it is given that we consider a circle with center O, AP comma PB are two tangents drawn from external point P. So we need to prove in this question RTP. We need to prove AP is equal to BP. AP is equal to BP. If you want to prove AP is equal to BP, for this theorem we need a small construction. The construction is, I'll just join the center to A, and I join AB, OB, and also I'll join O to P also. So a small construction is required. I'll just write the construction. So I join OA, OB, and OP. Right. And what we know, you can see this is a radius and this is a tangent to a point of contact. And we know the fact radius of the circle is always perpendicular to the tangent. So we have here 90 degrees, and also this is also a radius and this is tangent. Radius and tangent perpendicular to each other. Then here also we have 90 degrees. That means we have here two triangles. This is one triangle and this is another triangle. If you have to prove AP is equal to PB, this AP and PB are in these two triangles. That means if you prove these two triangles are congruent by CPCT, we can able to take these two values are equal. AP is equal to BP. Now we are going to prove these two triangles are congruent. What are the two triangles? One triangle name is OAP, another triangle is OBP. So I just consider the two triangles proof. One triangle name is in triangle OAP and the other triangle name is triangle OBP. So mostly these are 90 degrees we have here, also 90 degrees we have. So they are the right angle triangles. Right angle triangle means mostly we will prefer RHS rule. RHS rule to prove the two triangles are congruent. And once we will just check it that the two triangles are congruent with the RHS rule or not. R means right angle. Here we have a 90 degrees and here also we have a 90 degrees. So right angles are equal. H means hypotenuse. This 90 degrees opposite side is a hypotenuse, that is OP. This 90 degrees opposite side is also OP only. But here OP is a common side of the two triangles. Obviously hypotenuse are also equal. And one of the side we can take here OA is a one side and OB are also another side. OA is a radius and OB also radius. So radii of a same circle are equal. So by RHS we can prove the two triangles are congruent. So just write that. So first one I just write here in the triangle angle A is equal to in this triangle angle B, because radius is perpendicular to tangent. Second one, OP is equal to OB, common side. OB is equal to OB, that is common side. Common side. And next one, we can write OA is equal to OB. OA is equal to OB because they are radii of same circle. So radii of a same circle always equal. So by RHS rule we can write triangle OAP is congruent to triangle OBP. These two triangles are we prove congruent. If you prove these two triangles are congruent, then we can take in the two triangles AP is equal to BP by CBCT. So you can write directly AP is equal to BP by CBCT. So that's why we proved AB is equal to BP. That means the lengths of tangents drawn from an external points are equal. Hi. Today's theorem in circles lesson. Example 1. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle bisected at the point of contact. So we need to consider the given in two concentric circles, and you know concentric circles means a center is circles, a set of two circles with the same center we will call the concentric circles. So these are the two circles, this is one circle and this is the another circle. Both have a common center, so that we will call the two circles are concentric circles. In these concentric circles, if you draw a chord of the larger circle, if you draw a chord for larger circle, this is a larger circle and this is a smaller circle. If you draw a chord of the larger circle which touches the smaller circle is bisected at the point of contact. That means I'll just draw the chord for the larger circle. So I'll just draw a chord for the larger circle, and this is the chord for the larger circle. I consider this is a A and this is a B point. And this larger circle is touching the smaller circle at one point. That point I consider as a P point. At this point, it is bisected at the point of contact. They are telling at this point, the chord will be divided into two equal parts. So we need to prove in this question, at P point, the chord will be divided into two equal parts. They are AP is equal to BP. So in this question, we need to prove AP is equal to BP. That means overall, if you draw a chord for a larger circle, it touches the smaller circle at one point, and at this point, the chord will be divided into two equal parts. That means we need to prove here AP is equal to BP. Right? So I'll just consider this is a larger circle as a C1 and the smaller circle I just consider as a C2. I'll just write the given information now. It is given that C1 comma C2 are what circles they are? Two concentric circles with the center O, and AB is a chord of larger circle which touches the smaller circle at P point. So we need to prove in this question RTP. At this point of contact, we need to prove AP is equal to BP, that will be divided into two equal parts. So RTP is AP is equal to BP. This we need to prove. So for this proof also, we want a small construction. The construction is, what I do now, I'll just join O to A, and I just join O to B, and I join O to B. Right? So construction, join OA, OB and OP. It's a small construction I do. Now how we will prove this AP is equal to BP? You can see here, AB is a tangent for the smaller circle which is touching the circle at P point to 1 point. So we will call AB is the tangent for the smaller circle. So at that point of contact, we draw one radius, and here we will get 190 degrees, and here also we will get 90 degrees. And we know the fact radius is perpendicular to the tangent. Now, if you see here, we have two triangles. This is one right angle triangle, and this is another right angle triangle. And if you prove the two triangles are congruent, then we can prove AP is equal to BP. So let's go for the proof. So I'll just start with the considering the triangles. Proof. What are the triangles we have? In triangle OPA, one triangle OPA, and other triangle is OPB. So I just prove these two triangles congruent by using RHS rule, because they are the right angle triangles. We'll just preference to first RHS rule. RHS rule means RHS. What is R stands for? R stands for right angle. And we can see here, this is a right angle in this triangle, and that triangle also we have right angles, and right angles are equal in the two triangles. So what is the name of this triangle? Angle OPA is equal to angle OPB, because radius is perpendicular to the tangent. And second one, hypotenuse. This 90 degrees opposite side is OA, hypotenuse. In this triangle, 90 degrees opposite side is OB, that is also hypotenuse. But we know that OA, OB are the radii of the big circle. OA and OB are the radii of the big circle, then automatically the radii of the same circle are same. That means we can write here OA is equal to OB. They are the radii of same circle. Obviously they are equal. And one more, OP is equal to OB. In this triangle, OP, in this triangle, OP both are same, common side. Common sides are always equal. Then OP is equal to OB. This is common side. So by RHS, right angle, hypotenuse, and one of the side, by RHS rule, we can write triangle OPA is congruent to triangle OPB. We can write both the triangles are congruent. If both triangles are congruent, by CPCD we can write AP is equal to BP. So we can write AP is equal to BP by CPCT. Right? Hi, welcome to Math Loka. Today's question, circles lesson, example 2. Two tangents TP and TQ are drawn to a circle with the center O from an external point T. then we need to prove that angle PTQ is equal to angle 2 times angle OPQ. This is an external point. From T onwards, we have two tangents. One tangent is a PT, another tangent is a TQ. So then what we need to prove in this question, angle PTQ is equal to 2 times angle OPQ. So PTQ means we have angle, this is a PTQ. This angle is 2 times angle OPQ, this angle. So we need to prove this angle is 2 times that angle. For example, if I want to say this is a 30 degrees and this angle will be 2 times of 30 degrees, 2 30s are 60 degrees will be like that. So angle PTQ is equal to 2 times angle OPQ. We want to prove that one. So for that, I'll just write the given information first. It is given that a circle with the center, O, PT comma TQ or TP comma TQ. TP comma TQ are two tangents drawn from an external point T. Now, how we will prove this one? In this question, we will focus on mainly this triangle. You can see the triangle here. TPQ is a triangle. Then we will focus on here in this triangle only. If you see very clearly, we know that TP and TQs are tangents drawn from the external points, and we know that TP and TQ are equal. Let's start with like that. So TP is equal to TQ because they are the tangents drawn from an external point. So this TP and TQ both are equal, and these two are in this triangle. In triangle PTQ triangle. In PTQ triangle, TP is equal to TQ, then we can say that TPQ triangle is an isosceles triangle. So I'll just write TP is equal to TQ, so I can write a triangle PTQ is an isosceles triangle. That is an isosceles triangle. So what do we know? In isosceles triangle, two sides are equal and also two angles are also equal. Two sides are equal, automatically its opposite angles are also equal. So what are the opposite angles? So this is one angle and this is another angle. These two angles are also equal. So I'll just take angle. This angle is TPQ. TPQ is equal to angle. This angle is TQP. TQP. Then what I do? I'll just consider this is as a x degrees. Both angles are same, no? So I consider this is x degrees and this is also x degrees. Both I consider as a x degrees. And also I just consider this angle PTQ. This angle I consider as, let angle PTQ, this I consider as a theta. I consider for simple simplification. So this angle I consider as a theta. So in this isosceles triangle, these two are the equal angles. I consider as a x degrees and x degrees. This angle I consider as a theta. Now what I do now, like again same this triangle only, I will apply angle sum property. Sum of angles in a triangle is equal to 180 degrees. Angle sum property I will just apply. So in triangle, this triangle name PTQ, sum of angles is equal to 180 degrees. Then what are the angles are we have here? X degrees plus theta is equal to 180 degrees. X plus x, 2x degrees plus theta is equal to 180 degrees. Then 2x is equal to 180 minus this theta, I will send that side. Plus theta, another will become is minus theta. I want x here. X is equal to 180 minus theta by 2, then x is equal to 180 by 2 minus theta by 2. We have 2 ones are 2, 90s are. Then I have a x value is equal to 90 degrees minus theta by 2 degrees. This I consider as a equation number 1. I consider this is equation number 1. So x value I got here 90 minus theta by 2. This is equation number 1 here. So next what I will do, we have in the proof OPQ, this angle is there. I'll just make a small relationship between a small relation by taking that quantity OPQ we want. So what I do here, you can see here, OP is a radius and PT is a tangent. And radius and tangent always perpendicular to each other. Then we have angle OPT. This total angle is how much? The total angle 90 degrees. Radius is perpendicular to tangent. So I'll just take angle OPT is equal to how much? 90 degrees, because radius is perpendicular to tangent. Radius is perpendicular to tangent. And this OPT angle, if you see middle one line is there. Here they draw one line. So this line, what do this angle? That line divide that angle into two parts. This is one part, this is another part. So instead of OPT, I will write the two angles. What are the two angles? One angle is OPQ, angle OPQ, plus another angle is x degrees, which is equal to 90 degrees. So from here, angle OPQ is equal to 90 plus x, another side become minus x. Angle OPQ is equal to 90 minus, we have x value is there. X has value is there. What is x value? 90 minus theta by 2. So wherever is x, I'll just replace by 90 minus theta by 2. So I'll just replace it is 90 minus theta by 2. Then angle OPQ is equal to 90, minus into plus is minus, minus into minus is plus theta by 2. Then plus 90 minus 90 will be cancelled. Then I will get angle OPQ is equal to theta by 2. Then angle OPQ is equal to theta means I just consider angle angle PTQ is I consider as a theta. So instead of theta I will just write 1 by 2 means it is 1 by 2 into angle theta means PTQ, angle PTQ. I will send it to this side. Here division, this will become multiplication. So what I will get finally, angle PTQ is equal to 2 is multiply with angle OPQ. So that I proved angle PTQ is equal to 2 times angle OPQ. So that is proved. Angle PTQ is equal to 2 times angle OPQ. So in this proof, simply the complete simplification is connected within this triangle only. We'll just prove first isosceles triangle, then I'll just find the value of x, and I took here a small condition. If you substitute here, and we'll get the answer. Right? So instead of here, I substituted the value x is equal to 90 minus theta by 2. So just write here. Okay? Thank you. Next question. Example 3, circles lesson. PQ is a chord of length 8 centimeters of a circle, radius 5 centimeters. The tangents at P and Q intersect at point T, and find the length of T. We need to find the length of TP. So this is a figure. T is an external point. PT and TQ are the tangents. The given length of the chord PQ is equal to 8 centimeters and radius is 5 centimeters. So that we need to find the length of TP. This length we need to find. Before starting this answer, we need to take a small construction. That is, we need to join O to T. So if you join O to T, what it do actually? OT is bisect angle T, and also this OT is nothing but the perpendicular bisector of PQ also. So if you join center to T, it is bisects angle T, and also it is one of the property of the circle. It is bisect angle T, and also it is bisect the chord also. So if you join OT, it touches PQ, one point I consider as a R point, and this OT is nothing but a perpendicular bisector of PQ. It divides the PQ into two equal parts. So total length of PQ is 8 centimeters. At R, it will be divided into two equal parts. So PR is nothing but 4 centimeters, and RQ is also is nothing but 4 centimeters. Right? Now, I told you this is a perpendicular bisector, and it divides into two equal parts and also with 90 degrees. So here we have a 90 degrees, and here also we have 90 degrees. That means we will get here one right angle triangle, and this is also another right angle triangle. And if you want to find this TP, we want to find TP, a simple thing here, by drawing this OT, we got here two right angle triangles, and already we have, this is OP is a radius and TP is a tangent. Here we have one more 90 degrees. That means radius is always perpendicular to tangent. Here we have 90 degrees, and this is OPT. OPT is also a right angle triangle only. That means totally we have a three right angle triangles. If you apply for this three right angle triangles Pythagoras theorem, then we will get the answer. The simple thing, by joining OT, we will get two right angle triangles, and also we have one more right angle triangle is there. Simple thing, three right angle triangles. If you apply Pythagoras theorem, we have some conditions. After solving that conditions, and we will get the answer. So we'll just take one by one right angle triangle, and we will find the answer. Let me start with the construction what I consider here. Join OT, and it is perpendicular bisector of T PQ, and it divides the line segment into two equal parts. The two equal parts are PR and RQ. Then we consider first PQ is equal to 8 centimeters they given. Then by drawing OT divides into two equal parts. The two equal parts are PR, which is equal to RQ, which is equal to 4 centimeters. So it is divided into two parts. Now I'll just select one by one right angle triangle, and I will find the remaining values. So first I'll just consider, you can see here we have one right angle triangle. This is another right angle triangle. The whole thing is another right angle triangle. First I will take first right angle triangle. This right angle triangle is OPR. So in triangle OPR, I will apply Pythagoras theorem. Then here we have a 90 degrees. Its opposite side is OP. OP is the hypotenuse. Then apply Pythagoras theorem. Then we have OP square is equal to OR square plus PR square. Then we have a value OP is 5 centimeters. That means OP is 5 square is equal to OR. OR we don't know. So I'll just write OR square plus PR is a 4 centimeters, and it is a 4 square. 5 square means 25 is equal to OR square plus 16. We want OR square, we can find an OR square. OR square is equal to nothing but 25 minus 16. Then OR is equal to square root of 25 minus 16, answer 9. We will get, then OR is equal to, we will get 3 centimeters. So first right angle triangle, we got the value of OR, that is nothing but how much? 3 centimeters. Then I'll go for the next right angle triangle. But before going the right angle triangle, I'll just consider we have to find TP in this question. So I'll start with the, before taking the right angle triangles, let I consider that TP I consider as X, and remaining this quantity also we don't know. That quantity TR I consider as a Y. For simple calculations I consider there is X and this is Y. So this is a X and this is a Y. Now let's take another right angle triangle. You can see the another right angle triangle is PRT. PRT is another right angle triangle. I just consider in triangle PRT RT, then here we have a 90 degrees and 90 degrees opposite side is PT. Then hypotenuse is PT. If you apply Pythagoras theorem, PT square is equal to PR square plus RT square. Then how much is a PT? PT we have a X square is equal to PR is 4 square plus RT we consider as a Y, means that is Y square. Then we have X square plus 4 square. 4 square means 16 plus Y square. Then we cannot simplify anything here. From here X square is equal to 16 plus Y square. I just consider this is equation number 1. Equation number 1 I will consider. Then I'll just go for the next right angle triangle. Then we have a big right angle triangle. You can see OPT. OPT is a big right angle triangle. Here we have 90 degrees. So I'll go for the third right angle triangle. So I'll just go for in triangle OPT. Then here we have a 90 degrees. Radius and the tangent. Its opposite side is OT. Opposite side OT. O2 means nothing but y and plus 3, y plus 3. Then applying Pythagoras theorem, OT square is equal to TP square plus OP square. Then OT, how much is the OT? OT is nothing but addition of y plus 3, y plus 3, y plus 3 whole square. Y plus 3 whole square is equal to TP. TP is nothing but X square plus OQ is a 5 square. Then y plus 3 means we can apply a plus b whole square. What is a plus b whole square? It is a square plus b square plus 2ab. 2 into y into 3, which is equal to x square plus 25. Then I'll just write this as a y square plus 9 plus 2, 3 is a 6y is equal to x square plus 25. Then here also we have x square is there, y is there, y square is there. We cannot simplify this one. But we can do something here. And I consider this is equation number 2. If you see equation number 1 is the value of x square. X square value is 16 plus y square. So what I do here, this x square value 16 plus y square, I just replace here x square please. So I just substitute. So I'll just put x square is equal to 16 plus y square in equation number 2. Wherever is x square, instead of I'll just write 16 plus y square. So this is equation number 2. I'll just implies equation number 2. Equation number 2 is y square plus 9 plus 6y is equal to, in the place of x square, I'll just write 16 plus y square plus what I have here, 25 I have. Then I can cancel here y square and y square. Y square will be cancelled. And what is left here? 6y is equal to 16 plus 25 is 41 plus 9 another side is minus 9. Then 6y is equal to 41 minus 9, it is 32. Y is equal to 32 by 6. 2 table is possible. 3s are and 16s are. Then y is equal to 16 by 3. We got answer. Y value is 16 by 3. Y means what is the y value? Y value is TR value, but we need to find TP value. TP value means meaning x value we need to find. So if you substitute this y value 16 by 3 in equation number 1, equation number 1 is x square is equal to 16 plus y square, then we will get x value we will get. So I'll just put this y is equal to 16 by 3 in the equation number 1. I'll just substitute it. So in equation number 1, x square is equal to 16 plus y square, then x square is equal to 16 plus y value is 16 by 3 whole square. That is x square is equal to 16 plus the 16 square, if I plot 16 on 3, 16 square is 256 by 3 square is 9. I'll just write 16 by 1. Again we can find the LCM. The two fractions we have, x square is equal to 9 and 1 LCM is 9, and we can do the cross product because we have one of the denominator is 1. 9 16s are is 144 plus 256. then x square is equal to 256, 144 is nothing but 400 by 9. X is equal to square root of 400 by 9. Then what is x value? X value is nothing but 400 root is 20, 9 root is 3. And what is the answer? X value? X is equal to 20 by 3. Means x means what here? TP. TP distance we consider as a x. So x value is 20 by 3 centimeters. Okay? A simple thing. If you join OT and it is nothing but a perpendicular bisector of PQ, then 3 right angle triangles, if you apply the Pythagoras theorem, then we will get the answer. So we need to think like that only. Thank you.